This is the inside of that Bestek 150 VA pure sine travel potential converter, and it turns out there's a reason why the frequency on this thing isn't switchable. Because the way it generates the roughly 115 volts AC that it spits out is using a buck converter, which steps down the unsmoothed Ripley DC coming out of the bridge rectifier down to about 115 volts RMS, and then there is this MOSFET H bridge which acts as an anti-bridge rectifier. What these do is these switch the polarity of the output every half cycle hump of the output of the buck converter. Which one of these is a transistor, one of these is either a transistor if it's doing synchronous rectification, or it's a diode. Problem is, of all this elastic goo, I can't tell which it is. I'm suspecting it might be a diode, because this is something which doesn't really need synchronous rectification. Although, I know, might be implementing it, I don't know. Couple of interesting design features, because there is a 22 microfarad 400 volt capacitor here, which is the bus ripple suppression for this switch mode converter, which is what generates the electricity for the 5 volt USB charge ports. And of course that is isolated by this diode from the main buck converter supply, so that way this capacitor isn't back charging into the DC bus for that when the instantaneous potential of the output of the bridge rectifier is below whatever the stored potential in the capacitor is. Now, one interesting thing that it appears that they're doing, because there's no auxiliary power supply for any of the control circuitry for the buck converter, is it looks like they're running that off of the auxiliary supply from this switch mode converter, because the way a lot of these switch mode converters work, because the switching controller needs a supply of generally anywhere from around 10 to 15 volts at usually about 20 milliamperes or so to run the FET driver, because since they're switching a FET, that's that device under, that's half under that blob of elastic there, at, in the ultrasonics, it's going to take a certain amount of current to run it, simply because of the gate charge that it's constantly charging and discharging in that FET. And because that circuitry is usually capable of supplying relatively more than the 20 milliamperes or so that it's rated for, they're just using the extra probably a few hundred milliwatts at most to run all of the control stuff for the buck converter. So, interesting design detail, and yeah, it explains why it doesn't have the ability to switch frequencies. Because this is intended for use for things where it doesn't necessarily care, and it also makes the thing smaller, cheaper, and lighter, which, travel purposes is kind of important. However, having one of these which is capable of having that frequency adjustable on the output would be good, even if it be bigger and more expensive, because again, I'm not using this thing for travel, I'm using it for cheap stuff in a power lab. So yeah, there's a reason for it. It's just it's interesting design thing. Also, got the logo backwards on the silk screen.